Hi everyone, I'm Luca Actis Grosso and I work as an engineer in Bending Spoon. Today I will talk about Orion, our internal library that we use in order to build, train and scale our models. But before talking about this, I want to discuss how to create a deep learning project, because usually it can be divided in 5 main steps. The first one it is the project definition. It means create the GitHub repository with the correct folders and files, create the continuous integration pipeline, the test, the tinters. When everything is ready, you can start to write the code. So there is the model definition phase. In this phase, you define the network that you want to use, the number of layers, but also you define the data. So in this case, you define how to read them and how to make the transformation, and also maybe the augmentation that you want to apply during the training. When the data and the model are ready, you can start the training. So in this case, during the training, maybe you want to do a distributed training, so using multiple machines. Also, you want to monitor your training. So you want to monitor the loss, you want to monitor how the image that were generated by the models, and when you try different actual parameters in order to find the best model. The first step, in this case, you find your best checkpoint, solve your problem. Before going production, you want to optimize the model. What it means that you want to reduce the latency or reduce also the memory footprint in order to be optimized for your production environment. Now that everything's ready, you can deploy it in production. It means that you want to put the model behind the web server in order that you can handle some requests. So given a request, you can make the inference of your model and get in response the output. But it's not enough in a production environment, because you also have to make the monitoring, exception handling, all these functions that are added above the web server. There are hundreds of libraries that allow to do all these steps, but usually each of them are focused only on a specific part of the problem. For this reason, we decided to create Orion, because otherwise the researcher need to know hundreds of libraries that usually are different API that are not easy to combine everything together. Instead, this way, using only one API, you can do from the research to go in production. But Orion also enables us to do more things. For example, the hyperparameter tuning. It means that you want to run multiple experiments in parallel in order to try different type of parameters, because otherwise you don't want to wait every time that experiment finish before trying a different type of parameter. And you want to do it in a distributed environment on the cloud in order to be fast as possible. The other important thing it is the fault-tolerant training. What it means fault-tolerant? It means that you can be able to recover from software or hardware failure. This is particularly important when you work on the cloud, because it allows to use the preemptible machines, a machine that can be shut down in any moment. The advantage is that they cost much less than a standard machine. For this reason, we can move from a T4 GPU to V100, having at most 4x speed up at the same cost. Why it is important to use the most important performing GPUs? Because we can see the different GPUs have a different performance, for example, the convolution or the transform operation, so can reduce a lot the training time. The last thing is the reproducibility. So it means that you want to be able, given a model, to understand in the training what version of the code generates this training code, but also in the production, you want to be able to track back all the training loop we use for generate this model in production, but also the code used in order to make this happen. In order that if you want to restart the training or want to understand why there is a problem, you are able to do very easily. In the method section, we can see how to use our library in order to do the image enhancement problem. But before talking about this, we want to discuss how to use standard PyTorch code, because we can see there is a lot of boilerplate. In particular, we know that when we define the model and the data, you have to move to the correct device, that is a GPU or a CPU. But also, when there are multiple devices, it is even worse, because you have to combine, if you have put a 0, put a 1, and now make everything work together. When the data and the model and the correct device, you have to iterate over the number of epochs, and then for each epoch, you have to iterate over the number of batches. Then for each batch, you have to make the forward of your model, calculate the loss, then update the optimizer, make the backward. But Most of these operations are very repetitive and almost the same for every model. For this reason, we decided to use PyTorch Lightning as a framework in order to reduce the boilerplate and speed up the developer work. On top of this framework, we have created our classes that allow to solve our specific problem, like image enhancement, face enhancement, or video shortcut detection. So now we can see how to use the library in order to do a complete project. We start to create a new project from zero, so we have to create the directory and the files. For this, we can use the Orion CLI. It is based on Cookie Cutter. It is a Python library, a CLI utility that allow us to create a folder and given some parameters. After that, we work on the data. So we define how to create the data that we use during the training. In this case, we have the concept of factory zoo because on the Google Cloud Storage, we have a lot of dataset. And in this case, given a name, we can, using this class, automatically create the dataset that is able to read and process this data. And we can also define the transformation that we want to apply during the training. In this specific case, it is only a degradation function because given a high resolution image, we want to obtain a low resolution one in order that given a pair, we can use this pair during the training. So now we have the data, we can start to work on the engine. The engine can be considered like a wrapper of a PyTorch Lightning module. What it means that it contains the code for do the training, the validation, and the test loop. But also internally, automatically manage the optimizer and the updated learning rate. So everything that we see in PyTorch, it is more difficult. In fact, we can see in this case, we can define the generator and discriminator that we want to use. We can use different backbones, so we can use the same class but train different models. We can define which loss we want to use, and also define the parameter of the optimizer and the learning rate. Now that everything is ready, we can start training the model. So in this case, we can define how many GPUs to use, or maybe also the precision that we want to use for the data. So if there is a float 42 or float 16, so it means that we do a quantization. And what is important is that we want to log the loss function for the different experiment and keep track of all the information in order that we can compare easily the different experiments in order to, at the end, select the best one. For this reason, we have connected many different libraries like TensorBoard, but also weight and biases, that allow the researcher to easily compare the different runs and select the best model. Now that we have find the best model, we want to optimize. So in this case, we use other libraries like ONNX or TensorRT in order to reduce the latency time of the models, also the memory footprint, in order that it can be ready in order to put in a production environment. But before going production, a researcher can use a UI like Streamlit or Gradio in order to visually try the model. So in this case, you can upload an image on the UI and see the output of the model in order to see if everything's fine. When everything is ready, we can create Docker container that contain the code with a web server that is ready then to scale in a production environment. In the results section, we can see that we've used the library in many different use cases. For example, image enhancement, face enhancement, video shortcut detection. The main advantages of the library is that it reduced the training time on average of 25%. In particular, work on the data loading part, so improving how to process and read the data, make the transformation, but also improving how to use a better GPUs. The other part is that allow us to do knowledge distillation. It means that given a student network that is smaller, it learns from a teacher one that is already trained. In this case, we are able to transfer the knowledge from a teacher to the student layer by layer, because working in this problem that are using mainly GAN allow us to converge really fast using this technique, use a smaller network. The other part is that in the library we have defined integrated a different model and different backbones, so we can use the same class and train many different models in order to see what is the most performant one. In the shortcut detection, also we can see that we have defined many different datasets, because in this case it depends on how you define what is a cut and how to combine different video together in order to process and train your model. And also we integrate many different models that we use in order to find the best one. So to conclude, we can see that This library allows us to reduce the training time in average 25%. We have used it for more than 500 experiments during the last months. We have integrated more than 20 models and different backbones, and there are more than 10 contributors that are working on it. There are engineers that are working on improving, adding new features on the library, but also researchers that are continually adding new models. But this is only a beginning, because we want always to improve, so there are also other ideas for future work. We can see that one of them is to improve the data loading part, because when we work on images, in particular when you work in a cloud environment, the throughput in order to read the image from a remote storage can be a real bottleneck. So maybe a different idea can be to share the data in zip files in order to reduce the number of input-output operations, or maybe to use raw images. So in this case, you avoid the problem of decoding from a JPEG that also requires some time. The other part is the optimization in order to deploy on edge devices, because if you want to deploy on iOS or Android, there are libraries that allow to do it, but it depends on the operating system that you want to use, and also the performance can vary a lot one between the other. So you want to have a script that automatically finds the best model for each device that you want to deploy. At the end, we want to create a model registry. So it means we want to have a place where we can see all the models we have in production with the different versions, and see the performances in order to make maybe A/B testing, and also to have the lineage in order to understand the training corresponding to have this model in production, and also the code that generated all this loop. Thanks for the attention.